Okay, we're going to connect motion to displacement, velocity, and acceleration. Okay, we talked about previously velocity and acceleration being the derivative and second derivative of our s at t. I don't know if we actually connected that. The motion moving left and right, we talked about a little, is also known as displacement from the starting point of s and t. Okay, so how far have we been displaced? And we talked about in our last example, moving to the right being 6 units away or 2 units away and then getting back to where we started. That's what they mean by displacement. Okay, so object moving on a line is given this function, and we know that s at t stands for that. But it only exists when time is greater than 0, which makes sense. We don't go back in time. And s stands for meters, so meters displaced from the starting point. And t stands for seconds, how long it takes us to get there. Okay, so we've been given a lot of parameters for this question. Very first part of the question says solve velocity and acceleration at t equals 2. So we're going to go to a new page and then refer back to the questions. Velocity and acceleration, in order to do that, we need to find the first and second derivative of our function. So let's go to a new page. Our function was s at t was equal to 6t squared minus t cubed, as long as t was greater than or equal to 0. Okay, so velocity via t is also equal to s prime t. In other words, the derivative of this function. So we'll derive this function. That's going to give us 12t minus 3t squared. That's the derivative of this function. Okay, so we now have it in terms of t. And they also asked us for the acceleration. Well, acceleration in terms of time is equal to the first derivative of our velocity or the second derivative of our original function. So what we're going to do is just derive the above derivative we've found. So when we go to derive this, we end up with 12 minus 6t. So this will be our acceleration. Okay, so this is all question A. They also asked us to solve it when t was equal to 2. So we're going to take our velocity, and we're going to solve when velocity is 2. What is our velocity? Well, 12 times 2 minus 3 times 2 squared. That's going to give us 24. Subtract 4, 12. So we're looking at 12. And remember, we're in meters a second. Okay. Now, we're going to talk about acceleration. It's got a different units in terms of meters a second. We call it meters per second, or in other words, meters per second squared. And what that means is every second, how much faster are we speeding up at that second? That's why they call it meters per second. So our acceleration at 2, we use this equation, 12 subtract 6 times 2. Well, that gives us 0. Okay? So what that means is we are accelerating at 0 meters per second squared. Remember, it's a different unit value. But what it really means is we're not accelerating. Our velocity is constant. At this time, it is moving at 12 meters a second, and it continues at 12 meters a second at that time. Maybe at another time it speeds up. We're not 100% sure. Okay. So we have that information. That would be our A. So this object is neither speeding up or slowing down. It is moving at 12 meters a second. Part B of that question, we'll zoom in. Actually, let's look at the page. Part B said, when is it at rest? Okay. When is this at rest? So go back to a single page. Well, at rest is when velocity, and this was our equation for velocity. We had just solved it. It was 12t minus 3t squared. When is it at rest? Well, that's when velocity is equal to 0. That's when something's at rest, right? That's when if we have some slope, this is our horizontal, our tangent line. Okay? So we set velocity equal to 0, and we solve for the times when this could be at rest. So we take out a common factor of, we can actually make it negative 3t if we like. Negative 3t. And we're going to get negative 4 plus t. Okay? So this object, and when we go to solve that, 0 is equal to negative 3t, 0 is equal to negative 4 plus t. Good. This is t is equal to 0, and in this one, t is equal to 4. So our object is at rest at 0 and 4 seconds. Okay? That means it's either changing direction or maybe it's a starting point. Okay? 0 and 4 seconds is when the object is at rest. Jump back again. Third question. What direction is it moving at t equals 5? Now, direction we're moving. Remember, that had to do with positive and negative velocity. Okay? So we know we're on a line here. Let's go back to the other page. Zoom in. Again, we have our velocity, which was at 12t minus 3t squared. And they wanted to know what direction it was heading when time was 5 seconds. So after 5 seconds, what direction it's heading? Well, we need to figure out if velocity is positive or negative. If velocity is positive, okay, it's either moving to the right or up, depending on what kind of line they've given us. If we call it horizontal, it's going right. If it's vertical, it's going up. And if velocity is negative, then it is left or down. We know it won't be 0 because we just solved for when it was at rest, at 0 and 4. So it's definitely moving in a direction at this time. So we're going to solve for velocity at 5 seconds is equal to 12 times 5 minus 3 times 5 squared. That gives me 60, subtract 75. Yep. Which gives me negative 15. Okay? So we are moving in a negative direction. Whether it's horizontal or a vertical line, we're not sure. So we're moving they don't need to know a speed at this time. We could give it a speed, but it's moving at a negative, so it's either going left or down at this time. Okay? So if it was a vertical line, it was heading downwards. If it was a horizontal line, it was moving to the left at 5 seconds. I'm going to jump to a new page just to make a little bit of room. That was part C. There's a D to this question. They wanted to know when it was a positive direction. So when is it moving in a positive direction? Well, that's when velocity is positive. We just talked about that. Our velocity formula was 12t minus 3t squared. So to be in a positive direction, that's when velocity is greater than what? 0. So we need to set this equation to be greater than 0. So we have an inequality here. We have 0. Okay, 0 is less than 12t minus 3t squared. Okay. So what we're going to do here is we're going to simplify this. I'm going to divide the entire equation by negative 3. Okay. So both sides of the equation, each term by negative 3. Now when I do that with an inequality, anyone know what happens to the sign? Flips. Why does it flip? Anyone remember the rule? Because we're dividing by what? A negative. Okay? We're dividing by a negative, so our sign flips now. 0 divided by negative 3 is still 0. 12t divided by negative 3 is negative 4t. And negative 3t divided by t squared, negative 3t squared divided by negative 3t is positive t squared. Okay? What we can do now is I can rearrange this just so we have our t squared minus 4t, a little nicer to look at, or what we're used to. I'm going to factor out t, and we're left with t minus 4 times t. So, these are the options. Okay? This means there's two options when t is greater than 0. Okay? T is greater than 0 at what points? So let's think about this. Think of these as two separate terms. I'm going to call this term 1, This is our first term and our second term. Okay? And the reason I'm splitting them into terms is because if the first term is, sorry, let's think of it like this. We're multiplying these to get either a positive or a negative answer. Well, what was our goal here? We're trying to figure out when it's what? Anyone remember? Positive. We're trying to figure out when this is positive. So, what will have to happen? How do I multiply to get positives? Because these are two terms multiplied by each other. Well, to get a positive answer, my first term will have to be positive. And if that's the case, my second term will have to be positive. Or my second term will have to be negative. And my first term will have to be negative. Those are the only ways we can get a positive answer. If it's vice versa, we won't get a positive answer. Not what we're looking for. Now that I know that, I need t to be positive. So either, this is our first case. And by first case, I mean that this instance here, positive, positive, positive. Okay. For this to be positive, we need t to be greater than 0. And we need t minus 4 to be greater than 0. Okay? And in our other option, we need t to be less than 0, and we need t minus 4 to be less than 0. Well, let's write these as actual numbers. These are written fine, t greater than 0, t less than 0. How can we rewrite these? This can be t is greater than positive 4, and this one can be t is less than 4. Okay? Is that right? T is, bring it over. Yeah. So we have our cases here. We have when t is greater than 0, and when t is less than 0, and when t is greater than 4, and when t is less than 4. Okay? So, our options, only one of these actually makes sense. What happened? Sorry. Okay, remember we'd gotten to here. Sorry, we went back a little bit. We got to here, our first term and our second term. Now we know the only chances for this to happen are when, if t is going to be positive. Sorry, this is what's happened here. Our inequality is flipped now. Because our inequality is flipped, it's saying 0 is greater than that. In other words, we have negative terms. Our only options for negative terms is when the first term is negative and the second is positive, or the first term is positive and the second is negative. All right? Those are our only options for that. What we had missed is that because we divided by a negative term, our inequality had flipped, and I'd forgotten about that. I just kept going on when it was greater than 0. But because our inequality flipped, we're now looking for terms less than 0. Okay? So in order for this to happen, first and second term. Okay? So we need to talk about this. Well, if our first term's negative, that means t is less than 0. And if our second term's positive, that means t minus 4 is greater than 0. And vice versa, t is greater than 0 and t minus 4 is less than 0. Those will give us positive and negative answers. Well, remember, we did say this. This is case 1, we'll call it, and this is case 2. Remember, we said t had to be equal than or greater than 0. So we know that this is not an option in our case 1 in this one. Okay, so this is not an option. And in this one, we move 4 over, t becomes less than 4. Okay, so what we end up getting is t is greater than 0, but less than 4. So between 0 and 4. Our mistake was our inequality. I just flipped there. Okay. So that took out our first case. And then part E is just a factoring. I'm going to redo it again because it's missing. It says when does it get to its original point? Well, the original equation was this. And the original point, its displacement is 0 in terms of where it is. So we factor out t squared. We get 6 minus t is equal to 0. We get t is equal to 0 and t is equal to 6. So it takes it 6 seconds to get back to where it started.